That's it. Those are the things I wanted to say. Thanks for your attention. Now you know a little bit more about Truecaller, and it's time to hear from Edvin.
Hello, nice to see you all. My talk is called Refined Newtypes in Scala 3 with Neotype and Iron. That's a lot of words. There's a lot of slides and a lot of code, so let's get going. Just quickly about me. I'm Edvin. I come from Rocker, a Scala developer there, and I first encountered Scala like 10 years ago, something, when I was doing my master's at KTH, and I really liked it, the expressiveness and the functional style of it. And then I started working with C# and also a lot of Transact SQL, which is like Microsoft dialect of SQL. I wrote a lot of stored procedures, a lot of like more SQL than I ever thought I would. And it's quite a contrast from like, the Scala way. But the last 5 years, I've been doing Scala at Rocker. Yes, and Rocker is a Stockholm-based fintech. It was previously called Bing. And we provide financial services similar to a bank, cards, savings, credits. There's something called Rocker Pay, which is peer-to-peer marketplaces like Rocket and Blick. They use it kind of like Klarna. And our stack, we use Scala in the backend and mainly CU. And about a year ago, we were acquired by Nordiska, which is a bank. And now we have a lot to do. We're expanding to Finland and more stuff coming. So if it sounds interesting, we're hiring. Yeah, check this out. Okay, so this refined new types, I hope that it will make sense at the end of this presentation, but I'm going to try to explain it with some like practical problems. So not too much theory, because I don't know the theory either. Okay, so let's say it's Friday afternoon and you want to enjoy your weekend, but there's some like error report that some user wanted to make an order, but they can't find it. You think it sounds, you hope that it's just a one-off and you can fix it next week. And then another user says that they found an order, but they didn't expect it, so you're starting to sweat. Other users are saying that it's just giving errors, so your weekend is ruined. You start investigating this, and you check this, like you find some code, process, order, or some function. It's very well tested. You have unit tests, but you recently added some call site where you mixed up these arguments. So you're sending in the order ID where the user ID is expected. And some unlucky pair of users had their order and user ID mixed up. A bit contrived, but yeah, this is gonna cost you, your company, a lot of money. You might need to send like emails apologizing, maybe compensate, but most importantly, it's gonna ruin your weekend. So yeah, how could we fix this silly, stupid mistake? We could have some better test coverage, but it would be even better if we could catch this error already at the compile time. And The solutions for this, most common is, or one common is to, instead of using integers, use this, you kind of wrap these integers and create this user ID and order ID. And use them instead, and now the compiler is gonna give you a compilation error instead. It's gonna say you're sending in an order ID where I expect a user ID. Great. So this kind of works, but it has some issues because now there is one like performance issue with this. You're creating this extra user ID class, and there's some wrapping and unwrapping. Maybe not a lot, but it can affect performance. And also, when you want to, let's say you want to encode this user ID into JSON, the maybe default JSON encoding will be a JSON object with a value key. And this is not what you want. So you want it to be an integer in all these integrations. So you have to write all this boilerplate. You have to write your encoder. Yeah, it's annoying. And you also get some extra methods since it's a case class. Like copy. So can we do better? Yes, with opaque types in Scala 3, there's no longer any runtime overhead. So in this opaque type, it's only within this file that we know that user ID is an integer. So it's kind of hidden from the rest of the world. But the problem is that we end up with even more boilerplates because now we don't have this constructor anymore, and we can't do this dot value to extract the underlying integer. We tried a bit of this at Rocker, and it was annoying. We were looking for these batteries, and that's where we found this library called Neotype. So it says it's a friendly Newtype library for Scala 3. And you define your types, user ID extends Newtype int. So it's using opaque types under the hood, but it gives you a lot of extra functionality. So you get this constructor, so you can create a user ID with an integer. There's also this type alias thing, don't worry about that. And if you want to use it, like you want to encode your user ID, then all you need to do is import this interop source. There's a lot of these interop modules. And it might sound bad to have to import that, but you usually do it only once in some file where you're doing a lot of this stuff. So, and if you want to access the underlying integer, you get this unwrap function. And there's another library called Iron, also for Scala 3, that it says Iron is a lightweight library for refined types in Scala 3. And it does like almost exactly the same thing. Like if you compare this syntax, it also has this import, and it's called dot value instead of unwrap. Very similar, very similar. But yeah, you can use either of these to solve that problem with new types and not having to write as much boilerplate. Let's go to problem 2. I think you just got relaxed, but now I'm going to stress you even more. So you have some like financial domain, you have accounts, and there's this function adjust balance. takes in an account ID and an amount. There is no currency in this world. And if it succeeds, you get a unit, but it might fail with an insufficient balance because we don't want to allow accounts with negative balance. So it's gonna check that and fail. Sounds good. And then how is this used? So there's a transfer function with a source account and a destination account and an amount. And just a note about this source account. Like we could have used account ID there, but then we would have the same problem as before. We might mix them up. So you can have new types that wrap other new types. And so account ID is probably a new type, and source account ID is another new type. But there's a problem with this code. So in the implementation, we're trying to decrease the amount on the source account for the balance, and then increase the balance on the destination. And it should work good, but if we send in a negative amount, then if I'm going to send my friend money, that's how we think this is going to work. But if I send a negative amount, I'm going to steal money. So we're going to increase money on my account and decrease it on the other account. And what's worse is my friend doesn't even need to have the money, because it will fail on the second step here. That's where the check that he gets a negative balance strikes. So it might be time to look for a new career. Yeah, this I would not want to experience. So let's imagine what we do. We get to keep our job, and we're gonna fix the code. We start by going at this transfer, and we add this validation. Okay, it worked in my mind when the amount was positive. So we're gonna add an error that you can't send in invalid amounts. And we also replace this adjust balance with two functions, increase balance and decrease balance. And just to be safe, like we don't know, we're going to add a validation there as well. And this maybe works, but this is called like shotgun validation. You just scatter these validation statements everywhere and hope that your input is going to be caught in one of the blasts. This is like a code smell because it doesn't work that well, and we're always uncertain if can we trust our input. So can we do better? I think if we look at the transfer amount, couldn't we, like, instead of an integer, what if we had a positive integer? Let's just imagine that there is such a type. Then we don't need this validation. We can do the same for the other functions. We remove the validation there. And then we realize that this invalid amount error, like it can't happen anymore. So we can remove that as well. So this is better. We constrained our input more. And then we don't have to worry about this validation in the rest of our program. But yeah, how do we even define this positive integer? We can try to have an enum. I'm still writing it. Yeah, it's not that practical. We can try to do something smart where it's like a recursive you have one and then a successor. But this doesn't seem so fun to work with. But like if you can do this, this is quite good solution. For example, representing a non-empty list, you can do something like this. I would prefer that solution, but you can't always do that. So that's where this refine types comes in. So I don't know if you remember from school or if you ever learned this, but it's like set builder notation. Instead of writing the thing on the right with 1, 2, 3 up to 9, you say this set contains n, which is an element of integers such that n is greater than 0 and less than 10. So you cheat and you use a bigger type, and then you refine it. So you visualize it. You can have the large circle is all the integers, and then constrain it and get your type. Yes. So in Neotype, you can define a positive int. You create a new type like before, and you just add this validate function and override it. And you write plain Scala code, so you check that input is greater than 0. And one nice thing is you get this compile time checks for this. So if I try to create a positive int with 0, it will not even compile. Tell me that it failed the check. But it can also return a string. So you can customize the message to be more user-friendly. So yeah. And some more new type. The thing in the top, it compiles fine. And this example with the transfer, you can imagine that maybe you have a transfer request object that has it derives maybe Thursday codec, and you put already there your positive int, and then it's just gonna work out of the box when you try to decode this transfer request with a negative amount. It's gonna fail and say that your custom message. And the next line, maybe you want to create a positive int with something you don't know at compile time, like read from standard in, then it will complain and say, I can't do that. But you can use these alternatives. And one of the alternatives is to use the make function. And then you will get an either. Okay, Iron works similarly, but you can notice this like set builder notation. Iron kind of copied that. It's quite similar, and you don't have to use a new type for Iron. Kind of neat. You can take these types and create type aliases. It works fine. And if you try to do something that you don't know at compile time, you'll also get an error, compilation error. It will tell you to use one of its refine extensions. So you can do this instead. Refine and maybe using Iron this way, like this function, we apply some discount. There's a price, which is an integer, positive integer, and the discount percentage. You can do this nice interval closed thing and return a positive integer. But my eyes are like hurting a bit. There's so much text for my type, for my method signature. So you can put this inside those refined or these new types instead. Have readable code again. So I was wondering a bit, like, okay, we have Neotype and Iron. What should I use? How are they different? They solve basically the same issues. I mostly used Neotype. I'm very biased. I used it for like a year. Iron just tried for this presentation. So yeah. But one difference is that in Neotype, the Newtype and this validation thing, they're very coupled. But Iron, you can put this validation stuff outside of the new types in these constraints. And that's nice. And Neotype, I think this is a good advantage that you just write plain Scala code. You don't have to learn this type level DSL. And in Neotype, you can have more user-friendly custom error messages. But Iron has something that's pretty cool, that you can have implications between your constraints. I'm going to show another example of that later. But I tried to create like my own refined new type. So this was in Neotype. I tried to have something that checks a string and checks that every word in the string is capitalized. But it doesn't always work. Like, it says that you can just write plain Scala code, but it doesn't always work to have it at compile time. So it gave me an error that it couldn't do this compile time check with this. But I can still use this. Like, it's not broken. I can use it at runtime. So I can do this capital words .make, and I get this nice error message that can tell me which words are missing or not fulfilling the requirement. And with Iron, it works like you create this dummy capital words here and constraints. Then you have to implement this test. It returns a Boolean and implement a message. But note that the message doesn't it doesn't know about the input, so I can't do this nice custom messages. But I get the same issue here. It can't do it at compile. And it's telling me to use refine instead. But I can also, like with Neotype, I can use it at runtime either. Yeah, now this implications in Iron is very cool thing, I think. So I declare this x, it's an integer that's greater than 10. And then y is an integer greater than 5. And then I assign it. I assign x to it. And this compiles because it knows that if something is greater than 10, it's also going to be greater than 5. And I can have a function that is a positive integer, and I can send in this greater than 5 integer. So it knows that if it's greater than 5, then it's positive. But then I tried to do something more advanced, like something that's greater than 5 should also be greater than 0 or less than 0. But then it gave up, so it might be improved. And yes, so like practical experience, I used this for work, and there were some things that were missing from Neotype. Like, I think it didn't have the show instances. And but it was kind of easy to look under the hood and see how these integrations work, and I could implement it myself. I tried to do the same in Iron. We use Chimney quite a lot, but there wasn't any support for it in Iron. And maybe it's me, but it looked a bit more complicated under the hood. And learning from Neotype, sometimes you want to like reuse these validations, but you can't do it easily. So you have to stack these new types. So you can have one that's positive, then one less than 10 to create something that's between 1 and 9. Yeah, so summary, you should try these libraries. I think they help solve the problems I explained, and they're pretty cool. Nice Scala 3 libraries. Yes, so now for, I don't know how much time I have. If you have any questions?
Yeah, let's say you have and you define your own sort of proofs. So if you have those things built in right now, where greater than 10 is definitely greater than 5, but let's say you wanted something more complicated than that. Have you looked into how to define your own proofs that something is, if it's one criteria, it also automatically fits another criteria? And I assume that's sort of built in the libraries for these scope stuff.
The question.
Yes.
Yeah. So the question was these implications in Iron that greater than 5 is greater than 0. Can you do your own custom implications? Okay. And the answer is yes. This implication thing is a pipe class that is using this given mechanism to check if there's an implication in scope. So yes, you can definitely do that. Yeah. Yes.
Yeah, I have another question. So at the start of the talk, you were saying that case classes have negative performance impact. I wonder if you met this problem during like your work.
Question was if just using plain case classes for Neotype actually causes performance issues, and if I have experienced it, I don't think so. I haven't used a profiler or anything to pinpoint that. Oh, it was the case class. What's the issue? It's just something I heard. So yeah, not personal. Yes.
In the same domain, how does that affect your compile time? Let's say when you use a lot of new types with these implications.
Yeah, I'm not sure about Iron implications because I haven't used it enough. But this thing with like importing source type class instances, I think I saw that in a Scala 2 library, like Scala new types, they noticed that doing that approach affected compile time significantly. But I think that it has improved in Scala 3 because it's like using better built-in support. So I haven't experienced problems with yet, but maybe my services aren't large enough. Okay, one question.
Yeah, you mentioned at the start that you use CEO. Have you tried the new types of smart types or subtypes in CEO Prelude?
And the question was if I have tried the CEO Prelude smart types, and they have this new type implementation. It's similar to this. Yes, I tried it and used it in production. Not sure. Like, it had that problem that it didn't have this interop module, so I had to write to search the type class instances, and I think the validation was some DSL you have to learn. Okay.
Like, did you get into like this compile time errors? What was the like I got squeezed backwards all the time, but it wasn't standard like repeat.
Yeah, why I got the compilation errors on my custom capital words validation. I'm not sure. I didn't dig in too much, but it complained on this splitting the string, which is a bit weird. But it seems like it should work. It didn't. I don't know why. Okay. Thank you. Yes, thank you, Edvin. And I think we have